Hello everybody, this is Yakov Fain with Farata Systems. Today is lesson 8 of our training Intro to Java. Today we're talking about selected Java collections and what are Java generic data types. Java Collections Frameworks is a term that describes all classes and interfaces located in a couple of Java packages. One of them is Java Util, and the other one is Java Util Concurrent. So together, people refer to them as Java Collection Framework. There are lots of classes and interfaces in these two packages. Huge amount. Let's take a look. Check this out. This is the Java Util package. All these are classes and interfaces related to Java collections. Lots and lots of to pick from. We tried ArrayList, remember? Or Java Util Concurrent. These collections are used in cases when we have a situation with concurrent access, when multiple threads are trying to reach the same resource and maybe modify the data in some object. So all these are sitting in Java Util Concurrent. There is no reason to go and just memorize all of them, but we'll talk about the concepts, and at least you will have an idea where to find these collections as you need them. Collections are storages for similar objects. When you have a bunch of different objects and you need to store them somewhere together, then you store them in one of the collection. And again, as a reminder, we are not allowed to store primitives. We store objects only in collections. A couple of days ago, Java 8 was released, and it introduced lots of changes in the collections, and these are not a part of our training. I'm planning to record a separate video after this course describing the new features of Java 8. But meanwhile, if you're interested, you can take a look. You can follow this link and read about them ahead. Important part is for each method that is implemented for all collections, and there is something called streaming API. There will be a couple of other places where I will point or refer to this for each method. But again, this is not a part of this lesson yet. Java 8 is very fresh. Core collection interfaces. So there are groups of collections which can be called like category of collections. This image is from Oracle's online tutorial, and you see over here that they can be divided by collections can be divided by the following category, like sets, lists, queues, dequeues, maps, and let's see what are they. Sets in general is any set, any implementation of a set interface means that this collection does not allow duplicates. You can store objects in there, but you can't store duplicates in there. There are known implementations in Java such as hash set, tree set, link, hash set. So these are ready to go classes, but of course you can create your own using set interface. Lists are ordered collections. List allow duplicates, and lists support positional access. So you can say, give me the element number 9 or 10 from the list. Implementation for the list interface differs. For example, ArrayList that we've been using is an implementation based on Java arrays. So ArrayList is wrapping up sort of an array. So when you have this flexibility of adding or removing objects from ArrayList, which you don't have in array. Under the hood, Java creates all these manipulations with copying arrays from one place to the other. Another example is linked list. Linked list is not based on the array, but it's also a list. And the idea is that the object that is placed in the list just remembers a reference to the object that is next to you. In some cases, there are so-called doubly linked lists, which remember the object whoever is in front of you, and the object whoever is behind you in the list. Lists are useful if you need to do a lot of insertion or maybe removals of objects to and from the list. In that case, list will perform better than ArrayList, linked list, I mean. If you need to do just search in a list, in these cases, ArrayList will perform better. The linked list that knows the object in front of the current one and behind it are called doubly linked lists. The other group of collections is so-called queues. Queues are also lists, but they are built on the FIFO principle. FIFO means first in, first out. So imagine a line in a store or to a cash register where every person obediently stands behind the other one. Nobody cuts into the line or a queue. So whoever came first will be served first. FIFO. So these are the queues. So a couple of implementations here listed. Array blocking, queue, linked list. Again, you can create your own implementation the way you like it. Maps are mapping keys to values. A key value pair or pairs. So some examples are hash map, tree map, linked hash map. These classes implement a map interface. Let's see a couple of examples. ArrayLists again. So in this example, we create a new instance of ArrayList and add there two instances. One customer, we create an instance here, and we add it to the collection customers. Then we create a second instance of a different customer, Ringo Starr, and we add it to the same collection customers. Keep in mind that in this example, Java will not copy these two instances of the customer to the ArrayList. ArrayList just stores references to these objects in memory, so there is no copying involved in here. When you create a new instance of ArrayList, you can specify the initial size of it. For example, like 10 at the last line of this slide. I believe 10 is the default size of the ArrayList. And if you keep adding elements to this ArrayList, and if you added 10 already and you need more, you add 11th element, and Java will automatically increase the size of the ArrayList. It'll add another 10 spaces for another 10 references for new objects. And you can control actually how quickly grows the ArrayList. Getting object from an ArrayList. So add is adding objects, right? But get is getting objects. So this example shows you how you can get an object by its location. So in this loop, we are iterating through this collection customers, and we are getting elements one by one. And maybe we are calling some methods on each object of this collection. And this is an example where Java 8 made a substantial impact. So over here, we are in control, and we are saying, I'm going to go through this collection, and I will take in my hands every object, every customer, and I will call a method on it. In Java 8, it's a bit different. In Java 8, you say to this collection, I want to do something on you for each element, and moreover, you can pass to this method, which is on the collection, you can pass a behavior, an action. It's kind of unusual, but it's a so-called lambda expression, or you can pass the action, the function to be done on each element of the collection. This is what can be done in Java 8. In this course, we are in Java 7, so we can't do it yet, but we will. ArrayList can store anything and everything. It's like a kitchen sink. Any objects you can put in there. But, of course, you have to be careful when you are casting or when you are retrieving objects from there if they are different. Otherwise, you can run into an issue. Over here, I showed you an example of how you can run into an issue if you will take an object order of type order, and you put it in collection which is supposed to store only customers. No order should be there, but ArrayList declared in this way allows you to put anything in this collection customers. A bit later today, I'll show you how generics can help you out with this, to stop stupid programmers from doing this, from putting our orders inside the collection of customers. But for now, this code is legal, it's valid, but it's an error-prone code. So if you will be running through this collection, trying to do casting to customer every object blindly without doing any type check, then as soon as you will run into this order sitting inside the customers, you will get illegal cast exception. With generic, as I said, you can do a compile time check. If during declaration of this array list, you will specify, I want to keep their customers and only customers. Object of type customer. We'll see this example a bit later today. Let's do this walkthrough number 1. So what I want you to do, and maybe I'll do it with you. So you need to download and import the source code for lesson 14 into Eclipse. Then you need to add the following code at the end of the method main in class test. Look what I'm trying to do here. Over there in that example, we have a collection of customers, but I want to do on purpose. I want to add order into the customer collection. Let me open it up. I think I already copied this fragment of the code that you need to do. Let's read again. Open the class test and add the following code in there. Open the class test. It's here. Yes, I already added this code. You won't have it. When you will import this lesson 14, you will not have this piece of code, but I already added it there. Okay, now, what do I want you to see? Step number 3, I want to run it, so you will see an exception. Check this out. We have 2 customers in here. Line 11, it's David Lee, and line 13 is Ringo Starr. And then in line 19, I am adding an instance of a class order. Right-click, run as Java application. See? It printed the current customer is Lee over here. And then, where's the other one? The current customer is Star, and then it's messed up a little bit. It's Eclipse's problem. Then it's printed exception in thread main Java language class cast exception. Order cannot be cast to customer. A test in line 23. Line 23, we are trying to cast, right, to the customer type, but when it runs its order, it gets a problem. Now, step number 4, put the breakpoint and in the line 4 and debug the program and observe the content of the variable customers. Let's put this breakpoint over here, and now I will run it through a debugger. Right-click, debug as Java application. We are over here, and let's see what we have in this collection. Collection customers has 3 elements, and it has customer, customer order. The first guy is David Lee over here. We see this. The second guy is Ringo Starr, and then there is some order object. We can see that, right? Next step of this walkthrough, modify the class customer to look like this. So now, again, the customer that you imported was empty, but I want you to add a little bit of a code there. Again, I think I already did it in my case, but let's double check. Yes, I already added this piece. I declared in there a couple of variables, first name, last name, and a constructor that takes these values and assign them to the first name and last name. Next, add the following line to the end of the method main in class test. Over here. And you need to see why the program does not compile. This line is over here at the end of the method main in the class test. See, it's not compiling. It can't be compiled. Why? Because the current customer was declared where? Inside this block of code. See this? The declaration of the variable current cust is sitting inside the curly braces. Java supports this kind of a scope. If you declare a variable inside curly braces, anywhere inside of block of code, it's going to be visible only inside this block of code. That's why in this line 26, the compiler complains that I don't know what it is. Current cust, it's not a variable. So if I will move it up a little bit, I'm holding down the button Alt or Option and use the arrows on the keyboard, so you can copy blocks or lines of code easily this way. See, now it does compile. What else I want you to do? I move the println and let's run it again. This program again. Actually, we already did this, right? We already ran the program, and the current customer was Lee and star and exception. Order cannot be cast to customers. We did this already. Okay, let's move on. Different type of collections. Hashtable and hashmap. Representative of maps. Look at this. We create 3 different type of objects, and we want to put them in a collection, but we want to access these objects by some key value pairs, right? So first I created the instance of object customer, then I created an instance of object order, then I created an instance of some portfolio, and then I created a collection that is called Hashtable. Hashtable is one of the older collections. It's considered to be slow, but it is there. It's not deprecated, so let's use it for a while, for some time. So we create a collection, and then we add these 3 objects into this collection, into Hashtable. We add them, and we came up with names that we wanted. It could be any arbitrary name. In this case, I'm using strings to be used as keys in this collection. Customer, order, portfolio. It doesn't have to be a string, but it can be, a key can be in any object, and the value can be any object. In this case, I'm using strings as keys. To get an element from the collection, we put 3 different ones, as you can see, but they go by different names, right? So I can say, get me some object that goes by the name order. So of course, it's your responsibility to cast it to the proper type if you store different types of objects in the same hash table, and then you can work with it. What's the difference between hash table and hash map? There are several, but the main one is that hash table is synchronized, and the hash map is not synchronized. What does it mean? Again, we are not ready to discuss it yet in detail. When we will be studying concurrent access and multi-threading, we'll talk about it, but for now, just remember that if an object, or in this case, a collection is synchronized, it means that if multiple threads will try to grab the same object, only one of them will be able to do that, and the first one will place a lock, and it'll keep this object locked for as long as the method that we called on this object is not finished yet. So hashtable is synchronized automatically, and the hash map is not. So hash map is not, and which means that it may cause problems if you have a situation in your application when multiple threads try to change the same object. But if you don't have the situation in your code, then it's much better to use hash map because it's much faster. It doesn't place any locks. And in general, there are better replacement or alternatives for hash table. In particular, the Java util concurrent has a class called concurrent hash map. So use this one instead of hash table. Or if you want to use hash map and you want to make it synchronized, you can do it by calling this method on the class collections, synchronized map. All right. Next, iterating through a collection. Again, I show you the version 7 of the iterations. How would you do this in version 7 of Java? And then I'll mention again this new method. To iterate, actually there is not more than one way of iterating through a collection. Of course, we've been doing the for loops, but in here, I'm using the iterator interface. In here, I'm using the iterator interface. So what I'm saying here, I say to the customer collection, I say, give me a reference to your iterator. And I will be using this iterator to go through each element of this collection. When you use iterator, and then you just have a couple of methods, maybe 3 total. You can change. You can ask when you get a reference to the iterator special class. You can ask, do you have any next element in this collection? If yes, then you can call the method next. Give me the next one, and I'll do something with it. So next has next and next. These are 2 main elements. Also, when you are iterating a collection using the iterator, you can also remove elements from the collection as you go through them, as you iterate them. So in Java 8, I highly recommend you to consider for each method on the collection instead of using iterator. Linked list, it's another collection, and it's useful, as I said already before, when you need to do a lot of insertions and or removals from the collection. You are removing nodes. And it's pretty easy to use. You create a linked list. You add some elements to this list. In this case, it's passengers. And then to iterate through it with iterator, you can say, give me the reference to your iterator, and then you do next, next, next. So pretty simple. Second part of this lesson is about Java generics or generic types. What is a generic type? Generic type is a type which is generic, but allows you to specify parameters, or sometimes they say parameterized data type. You can create your own class and specify what are you planning to store in there. Generic type is a type with parameters. For example, ArrayList is a generic type. We are about to start using generics more and more, but we already had a simple example in a couple of slides back. So it allows you to specify concrete parameter. What do you want to put in the array list? Let's look at the documentation. If you will open up the Java doc for array lists, following this link, you will see this definition of array list. Array list and then something strange in angle brackets. This something strange is a placeholder where you can put a concrete name of the data type that you are planning to store in this array list. Of course, array list, I'm just using it for an example, but there are lots and lots of parameterized data types in Java. So, what is this E? E can be an arbitrary letter, but E, there are some conventions. E is standing for element. So you're saying the array list can store different objects, and when you will be using it, you can specify which objects you want to store there. If you do that, compiler will help you out to make sure that you will not accidentally put in there something that don't belong to this array list. Check this out. We declared an array list and we said we are using parameter. We are saying I want to store in this array list only instances of the class customer. So you put these angle brackets over here, and when you in the new operator you also use angle brackets. They call it diamond operator. In version prior to version 7 you had to repeat the word customer over here, but not anymore. So what will happen in this case? I wrote in there, do you want to store cats and dogs in the same array list? In some cases, maybe you do, but let's say you don't. So what you do is you declare an array saying that you are going to store customers in there, only customers. You add a new customer, David Lee. You add a new customer, Ringo Starr. And here you're trying to add a new order like we did 5 minutes ago in the walkthrough. And now it's a different story. Now compiler will complain. Compiler will say, no way, you can't do this. You said that you are going to put customers in this array. Don't even try to give me this order. It doesn't belong there. So we are getting compilation time error, compile time error, which is, of course, a lot better than getting a runtime error, right? During compilation, we can fix it. And when you will be iterating over this collection, you don't need to cast it anymore. If you declared it as a collection of customer, then you can just get elements from there and do something with each element without the need to cast it. If you remember sometime back, where was it? Over here, for example. See? In this case, in walkthrough, we did not use generics, right? So when we were getting elements from the array list, we had to explicitly cast it to customers. Why? Because generally, array list can store any object. But when you are using generics, you don't need to cast, because during the declaration, we already specified that there will be customers in there. Compiler double-checked it, and everything is clean. Walkthrough number 2. So what do we want to do? We want to download and import the source code for lesson 15 from the textbook. All right, I already did that. Run the program test generic collection. It's supposed to print this. Customer David Lee in the method do something, right? And then Ringo Starr. Let's go there. So this is lesson 15. Test generic collection code, right? So the instruction says uncomment line 16 and 17. Uncomment them. And save. Command S. Immediately I'm getting an error. See, compile time error. The method add customer in the type array list customer with generic parameter, is not applicable for the argument order. See, compiler tell me, what are you doing here? You declared an array list customer in line 10 to store only instances of the customer class. But now you're trying to give me an order. So see, compiler helps you out now. By the way, this example I wrote originally even before Java 7, and that's why I repeated the type customer over here. But I will remove it from there to use this so-called diamond operator, which is valid starting from Java 7. We did that. Observe compilation error. That's fine. Now, continuing, remove the both customer again. We have only one customer. Parameter line 10. Compiler will stop complaining. See, compiler complains. If I want to say, don't worry about it, I am removing the type over here. Obviously, I need to remove completely. And angle brackets. Like we did in the past, right? You just declare a type without generic parameters, without the user using parameters. Compiler doesn't complain. But now what we have a time bomb that will blow during the runtime. Let me run it. See, time bomb. The third element doesn't belong there, order, and so on. So illegal cast exception. So generic parameters, generic data types definitely help. In the previous example, we used some parameters that were given to us by creators of the Java language. But what if you want to use this feature for your custom classes and you want to create some classes that can take parameters? For example, in this example on the left, I took Actually, the whole example I took from Oracle's tutorial. Here's a link. But let's say we want to create a class box. And people can put in boxes different things. So we want to define a parameter. T stands for type. We want to define a parameter. So when you create an instance of the class box, you can limit the programmer who will be using this class to a particular type that can be placed inside the box. So T for type, right? So you declare a variable. It's kind of strange, right? You're saying a variable of type T. What is a type T? Type T is a parameter. Type in this notation, in this syntax, you say, I don't know what is T, but when somebody will start using the class box, they will tell us what T is. They will tell us what do they want to use as a data type over here. So so in this case, we have the method add. You can add something to the box, and you can return something from the box. You can extract something from the box, right? And again, return type is what? T. What is T? They'll tell us. And on the right-hand side, you see the usage of this box type. You declare a box to store integers, right? You declare a box to store integers. And then you can add them. You are adding a new instance of integer, and you can retrieve them. Get from that box, we are calling this method, and there is no need to cast, because the compiler, when compiler built this project, it figured out that you are planning to work with integers there. So in the bytecode, there is a reference to that object in this program, in the box demo 3, that collection actually has integers inside. But there will be a slide on type erasure. From the in the bytecode of this class box itself will look the same as if we wouldn't. Actually, it looks the same if we wouldn't use the parameter T. I'll explain it to you in a minute, in a separate slide. Commonly used parameter names: E for elements, K for key, N for number, T for type, V for value. And we'll have an example with K and V pretty soon, in a couple of minutes. And walkthrough number 3. There is a project in Eclipse Generics which I created several days ago. You don't have it in lesson 15, but I put a link to the Git repository where I started to add some more Java examples. You can find them there. So I just created a different usage of the box that we discussed just a minute ago, of the box class. I want to put there not integer, but I want to create an application that will be shipping mobile phones. So we will be shipping boxes with phones, different type of phones. So I will open up this example, and let's look at the error over here in line 14, and let's fix this error. Oh, just a minute. So this is the code of time to ship. A class with an error over here that we will fix. But for now, let's check this out, the box. The box is exactly the same as on that slide with parameter T. BlackBerry.java is just a simple class with almost no code. I'm in BlackBerry. Nokia is another simple class with almost no code at all. By the way, I was planning to create a class iPhone. When I wrote the iPhone with small I thought to myself, it's wrong. A class is supposed to be supposed to start with the capital letter, the names of the classes. So then I said, all right, so let me do capital I in iPhone. Then I thought, no, this is also wrong, because naming convention says that if a type starts with the capital letter I, it's an interface, not a class. Also, it's bad. So I decided, the heck with iPhones, I will be putting in boxes Nokias and Blackberries. So then, shipping order. We want to be able to create a class shipping order with parameters. So I'm saying the class shipping order can get as a parameter key and a value. Key would be the order ID, for example, and value would be the content of the order. So pretty simple class with two parameters, key and value, right? And a constructor, shipping order, which will take the actual concrete parameters when somebody wants to use this class. And time to ship is the program that will be using all these boxes, BlackBerries, Nokias, and shipping orders. Time to ship. I create a new instance of the box. Not just the box, but the box that can store Nokia phones. Parameter for the box here, concrete parameter says Nokias. Then I create another box which will store BlackBerries, right? It's a different box. Then I'm saying, now I want to create a shipping order. Look at this declaration. Shipping order itself was declared with K and V, unknown sort of parameters, but now it's time to replace those abstract parameters with a concrete one. So I'm saying that the first parameter will be string, and the second parameter will be box of Nokias. Value is box, and not just the box, but the box of Nokias. Then I create a new shipping order. I gave an ID PH1234 to the order, and the content is the box of phones. And now I want to create a second shipment, a shipment of different phones of BlackBerries, right? And I did a mistake. There is a mistake which we need to fix immediately in line number 17 over here. So what is the mistake? Let's read it. Type mismatch. Cannot convert from shipping order string box Nokia to shipping order string box BlackBerry. So what is the error? Compiler again gives us a helping hand. Compiler says, you are saying that this shipping order will contain string as the first parameter and a box of BlackBerries as a second parameter. So why do you give me this? And what is this? Box of phones. Box of phone is a box of Nokias. You said in line 16 you're going to give me a box of BlackBerries. So give me a box of BlackBerries. Right? See, compiler stops you from making mistakes. So what do we need to do to fix it? Instead of giving it box of phone, I will give box of phones 2, which is declared in line number 9, which is a proper box of BlackBerries. Now compiler is happy, there is no errors. Of course, we can run this program. Don't expect to get a shipment of phones, but it works. It did work. Okay, we are almost done. So type erasure. So think of it this way. When you declare something with parameter or without parameter, compiler will generate bytecode the same. Both of these lines will generate the bytecode for customers variable the same, and it's so-called row type. So technically, that's the word erasure, the meaning of it. It means that compiler will erase this parameter. You used it for a little bit, just during the compilation time, just to help you out, and we don't need it anymore. The only difference in the code of the program that uses the bytecode of the program that uses this ArrayList customers is that it'll make a little mark somewhere when you maybe will be looping through this ArrayList. It'll put a mark saying that ArrayList has customers. So don't need to cast the customers. We know it already. This is what the type erasure means. And the other thing is that you can use the wildcards in parameters when you declare parameterized types. So you can use the question mark saying in this type, so in this class, you can use parameters of unknown type, unknown yet. Or you can say something like this. Question mark extends customers. You can say that in this type, you can put only subclasses of type customers. the customers itself and its subclasses. In this case, it says that this parameter means that you can use over here only the superclasses of class customer. And here's an example. You can say ArrayList question mark extends customer. It means that this ArrayList will allow you, compiler will make sure that you will be placing there only customers and its subclasses. Okay, and we are done for today. Homework, just do the try it section exercises from lesson 14 and 15 from the textbook. And that's about it. Additional read a little bit about linked list, study Oracle tutorial on Java generics, and watch the presentation on Java generics from Java 1 conference. And here's another example for you to read. That's about it for today. Thank you very much for watching this video till the very end. My name is Yakov Fain. Yeah, I work for Arata Systems. And till the next lesson. Bye-bye.